Good evening, and a very warm welcome to the first masterclass of the internship program. My name is Ria, and I work as an associate manager at CSR Box, and we're bringing IBM SkillsBuild directly to you at zero cost. We hope all of you have received free lifetime access to the platform by participating in the orientation session or after watching the recording in case you were absent. Please don't forget to complete the activity and mark your attendance through the Google form that we've already shared with you. Also, please ensure that your organization is CSR Box on your profiles, or else we won't be able to track your progress and offer you the internship certificate. You can find a tutorial on where to find your partner organization in the chat box now. In case your organization does not show CSR Box, please register again using a new or a different email address. Make sure you're registering through the QR code or the registration link that has been shared by us. Once you're successfully registered, please fill the Google form and inform us of the changes in the email address. You can find the link to the Google form in the chat box now. You can also make edits to the team by filling the section 2 of the same Google form. And if you've not received the offer letter, please fill the third section of the Google form and we'll process it for you. Additionally, the link to the learning activity has been dropped into the WhatsApp group. Please ensure that all members are completing the badge courses and uploading the learning certificates on the link that we will provide later. The deadline for this is 26th of July. This is the first deliverable of the internship, and submitting the certificate by every team member is a mandate. This concludes all the announcements that we have to make, and now we move on to the exciting part. Presenting to you the very first masterclass of the program, which is an introduction to artificial intelligence, from its history towards the future and everything in between. I'm very, very excited to introduce to you the speaker of this masterclass, Mr. Amit Tiwari. Amit is an entrepreneur and an AI consultant for IBM SkillsBuild. He's done his bachelor's in electronics engineering with a specialization in artificial intelligence. And his current research is in NLP and computer vision. Amit has conducted 100+ hours of masterclasses in various topics of artificial intelligence. Over to you, Amit.
Thank you so much, thank you so much, Ria, for this amazing introduction. Hello, everyone, and welcome to the first masterclass of Introduction to AI. I congratulate all of you for coming to this internship and taking a step towards learning AI in this world. As you know that the world is changing really, really fast. And to keep up with all the technologies, we need to upgrade ourselves each and every day. So to begin with, AI is the current technology that is in boom for the last 4 to 5 years. And it has been at the peak of its time. It is the best time to learn AI. Today, I'm going to introduce you to the world of AI and how AI has been with us for the last 60 to 70 years. And I'm going to introduce you to the core concepts of AI, like machine learning and what is the difference between AI and machine learning. I have a lot to teach. I'm really, really excited. It's a lovely weather in Ahmedabad today. I'm from Ahmedabad, so I'm teaching you from Ahmedabad. I hope that you are also enjoying the rainy season that is there in your states. So let's get back to the session. It's going to be a fun ride. You're going to learn a lot. I have some norms for you, which I will introduce you later in this class. I hope that my slides are being shared. All right, so this is a story. The first lecture is actually a story of how AI changed my life. my life before March 2023, I was a CEO of a digital marketing company. I was running my own company, and I also had a food business. And the person that you see on the right here was the face of me every day after returning from the office. Frustrated, stressed, don't know what to do because I was doing all these things. So, as you know, with great power comes great responsibility. I hope that's a quote of Spider-Man. He is my favorite character in Marvel. But nobody told Spider-Man that with great responsibility comes more work, and with more work comes more stress. So if we talk about the first order logic, we can say that with great responsibility comes more stress. The more responsibilities that you have in an organization or whenever you go to work, the more stress it will create it because of the work that you are going to handle. So this man that you can see here was the face of me, as I have already told. This was my daily story of coming back from office frustrated and stressed and not knowing what to do. And why my situation was like this? Because as a team and as a CEO, and we had like 8 people in our team. It was a small team because we were handling few clients. But nonetheless, the task was too big because we were mailing to clients, to team, to vendors, to partners. I was writing these mails personally. My team was handling these mails for me. And what we were also doing as what I was also doing as a CEO and my team was doing was we were filling up sheets of finance, inventory, client data, performance, strategy, planning, and whatnot. We had like tons of sheets to fill every day, and we lagged behind in filling all these sheets. We were also writing documents because we were a digital marketing company. We were writing proposals to our clients, marketing plans. We were doing admin work, copywriting for ads, stories, and ideas. And we were also designing images like ads, posts, logos, menu, flyers, posters. We were doing image processing. We were enhancing our images to get it back to the ad or to the poster. And we were also making YouTube videos for promotions, ads, social media marketing, and whatnot. And finally, we were making PowerPoint presentations for proposals, client meeting, pitch, and performance. And all of the tasks that I mentioned to you, like all these 6 tasks that we were doing each and every day, me and my team, we were spending more than 8 to 10 hours of our work time in doing all these redundant work that we were doing every day. So that left nothing for us to be creative and to really do the work that we should be doing. I mean, I should focus on handling more clients or getting more clients as a CEO. My team should focus on the work that they were on, but they were like being fed with all the admin work that we were supposed to do as a company. How my life changed was in November 2023, I heard that all of the tasks that we were doing could be done with the help of AI tools. And I am an AI graduate of 2014. That means my batch was 2010 to 2014. And my branch was electronics and communication engineering. And AI was my specialization. But at that time, when we were doing it in 2014, like, that means 10 years back, we were mostly working on algorithms, mathematical calculations, prediction, classification, and how to model all these things. And we could not imagine that in the next 10 years, that means that jump back to 2024 in the world that we are right now, we could not imagine that we will be able to do all these tasks. Like AI will understand our language and it will reply in our language itself. Like we could be writing mails with AI, we could be designing images with AI, we could be making videos with AI. We never imagined that in the 10 years, AI will achieve that much. And when it happened, I jumped into the world of AI. And since March 2023, I have been researching in natural language processing and computer vision. Also, I am using all these AI tools like ChatGPT, Gemini, and whatnot. There are many advanced tools that I will explore, that you will also explore in this in the tutorials that are going to come in the next master classes. So all these AI tools can do all the works that we were doing. And now in 2024, I save 5 to 6 hours every day outsourcing all of my redundant work that I was doing before I was using these AI tools. And in 2024, it's an amazing time to be alive because all the work that was redundant and we were doing it on with our hands, either by typing or by using Photoshop or by using any other tool, they can be outsourced to AI, and AI does it wonderfully. It's an amazing time to be alive because this is one of the technology that is advancing in like with a speed that we are not even able to imagine that what we will be able to achieve in the next 10 years. And 2024 is the perfect time to learn AI because AI is in a baby stage right now. It's booming, and the people who will take up and learn AI will be far ahead in this race of either securing a job or to do a business in AI. Then the people who are not adopting and adapting this technology. This happened with internet in in the early 2005s. So what internet, the people who adopted internet and the technology that was happening in 2005, they are far ahead in the life in 2024 than the people who left behind. So the right technology to learn in 2024 is AI, and it's an amazing time to learn AI. And I congratulate that all of you are taking a step in learning AI and enhancing yourself so that you are ready for the world that is going to come. And in this whole internship, what you are going to learn is in the first masterclass being Introduction to AI, what AI is, what is the history behind AI, what are the core concepts in AI, what is machine learning, what is reinforcement learning, all these simple concepts you are going to learn in the first masterclass. Along with the course that you are doing, the Fundamentals of AI course by IBM, you'll be able to grasp all the concepts that are necessary to step into the world of AI. In the second masterclass, we are going to learn about generative AI and how it works, how ChatGPT works, what is the underlying principle behind working of ChatGPT, what are large language models, and how are the transformer structure is helping in these large language models. So it will be an in-depth session on how generative AI models work. The third one is very, very popular in today's world, which is prompt engineering. So I will be explaining you the concept of how to write an effective prompt, how you can engineer your prompt so that you are getting the most of the generative AI that we have in the market today. Then we are going to dive deep into making our own AI system. That means we are going to design our own chatbot. And then we are going to learn about machine learning, and we are going to design a machine learning model that predicts some output on the basis of some data. So exciting 6 masterclasses for you, and that has been brought up with the help of IBM as well as with the help of CSR Box team. So a huge thanks to both of these companies, and I take you in the world of AI. So a little bit of disclaimer before I start the class. So I will use English to teach. There are people who will be able to understand this better in the vernacular language that they speak, either it is Gujarati or Hindi, but I have the constraint of using English because there are people from all over the states of India, and then there are states where Hindi or Gujarati is not being spoken. So I'll be able to use only English in this. Although I'll be using simple English, so it will be you will be able to understand most of the concepts that I'm teaching in this class. Second thing is, this is an introductory class, and I have prepared this lecture so that everyone can understand this easily. That means some of the concepts you will be able to understand, which are very, very basic and very, very ground level concepts, but nonetheless very, very powerful one if you're stepping into the AI world right now. Third one is that I can only ignite spark in you. That means we have 12 hours between you and me that I will be teaching for these 12 hours. But in those 12 hours, it is not enough to learn AI. But I can ignite the spark in you. That means that I can introduce you to the concepts. How you are taking these concepts and building it up to flame depends on how much fuel you have. That means that you need to do your own research. You need to go to YouTube. You need to read research papers. You need to go and read articles after I introduce you to some concepts, so that you are adapting these concepts and learning these from all around the world. the knowledge is actually free in these days. You can learn any skill from YouTube as well as research papers. They're all available on internet, but you need to know what to learn, and that is why I'm here to guide you in this journey of AI. Okay, so I have created some polls and questions for you also, so that I'm not the only person who is talking in this. You are also interacting with me. So please uh, answer these poll questions. I'm going to start the first question. And the first question is here. Okay, so I have launched this poll. You just need to answer this question from clicking on the answer. Okay, so the question is, how much do you know about AI? So the first being, I have never heard about this. That means that you have no knowledge about AI. Second option is you have heard about AI maybe in movies, books, and know a little bit about it. Third option is I have worked with AI tools like ChatGPT and watched some YouTube videos regarding it. Fourth one is I know about AI, I know some basics as well as advanced concepts, and I'm interested to learn more. And the fifth one is I'm an expert in AI. What the hell am I doing here? Okay, so whatever you are, whatever skill of AI that you have, please let me know, so that I also understand how much you have knowledge about AI and what do you know about AI. And I see that a lot of people have already worked with ChatGPT and watched some YouTube videos regarding AI. That means that you have already started your journey of AI. So I congratulate all of you, those who are already knowing all these tools. The people who have not heard about AI, or those who have heard about AI in movies, books, and know a little bit about it, your journey is just going to be amazing, because I'm going to teach you some of the concepts which you have just read or heard somewhere. So we are going to have interactive sessions. We are going to have some heavy theoretical sessions, but a combination of it is what makes this internship amazing. All right, thank you so much for participating in this. And I'm just going to end the poll. All of you have answered. Keep participating like this, so that I know that you are focused in this class. 80% of you have answered this question. So thank you so much. I'm just going to share the results. So 59% of you have known about ChatGPT and you have watched some YouTube video regarding AI. And 15% of you have already heard about AI from movies and books, and 24% of you know the basics as well as some advanced concepts, and you are interested to learn more. Wherever you are in your journey, I welcome you all to this class, and let's move ahead with this. Okay, so I'll be just going back and okay, so let's begin with the elephant in the room that we are going to talk about, which is artificial intelligence. What is artificial intelligence? You are all here to learn about AI, right? So I would like you to just give me this answer of whatever you think about what is artificial intelligence, the answer to this question. Use the chat box to answer. So you will be sending it to me as a chat, and I'll be reading some interesting answers from all of you. What is your definition of AI? 59% of you have told me that you already know about AI, right? So let me just know in the chat box. Quickly type your answer. What is artificial intelligence? Let me know in the chat box. I'll be reading your answers, and then I will be building up my own definition. That means the engineer's definition of artificial intelligence and what it really is. So I'll be waiting for your chat responses for the next 1 minute, and I'll be reading some of the interesting answers there. So you can directly do a direct message to me. That means you will be seeing Amit Tiwari as the host. So you'll be directly messaging me. You can also message any of my teammates. They will be able to read these answers to me also. All right, so I have already started getting these answers, and Niharika is saying that AI is actually a machine who has the ability to mimic like human brain. Very close to the definition. This is actually right. A machine which can mimic human brain is called an artificial intelligent machine. Okay. Mohammed Kaf is saying that artificial intelligence is a set of technologies that enable computers to perform a variety of advanced functions, including the ability to see, understand, and translate spoken and written language, analyze data, make recommendations, and more. So he's talking about all these advancements in technology like translation, natural language processing, analyzing data, making recommendation, and more. You are very, very right, Kaf, in defining the artificial intelligence, that it is a set of technologies which enables to do all these things. I'll read two or three answers from you. Amazing, amazing answers I'm getting. And thank you so much for giving all these answers. That means you are engaged, you are focused, and you are learning, right? I'll be reading some more answers. I'll not be able to read all of your answers. I'm just randomly selecting. So no offense to anyone if I'm not reading your answer, okay? So Nicole is writing me, yeah, I just lost the answer. Okay, so I'll read this one. Priyam is writing, AI refers to computer system that can perform tasks typically associated with human intelligence, such as reasoning, learning, and problem solving. These systems use algorithm and data to simulate intelligent behavior. And Drew is writing, AI is one type of robot which reduces human work and effort, work faster than human. Okay. And Trish is writing, it's a branch of CS that deals with the creation of intelligence. That's also a very intelligent answer. And I will read the last one, which has come to me by Charu Sharma. And she's saying that artificial intelligence is the science of making machine that can think like humans. It can do things that are considered smart. Thank you so much for all of your interesting answers. All your definitions are correct. The definition that I have read. And actually, in reality, artificial intelligence is nothing but it's a computer program that can think, learn, and make decisions similar to how humans do. Basically, if we could create a computer program that could work like humans, that can think, learn, and make decisions similar to how a human makes decisions, then we will call that machine an artificially intelligent machine. Okay, so basically, we are in a search of an algorithm that can actually solve all of the tasks, that can do all of the tasks that a human can do. Okay. We divide AI into three categories: narrow AI, general AI, and super AI. So in our scientific world, where we researchers, we categorize AI into three categories: the narrow AI, the general AI, and super AI. So basically, what we have as a general AI, narrow AI, is the AI system that are designed for a specific tasks. AI systems like virtual assistants like Siri and Alexa and OK Google, if you have used it before, they are designed for specific tasks only. As someone mentioned, that AI is a technology that can do tasks like image recognition, speech recognition, and natural language processing. So these tasks, if there are only specific tasks that an AI can do, then that AI will be called a narrow AI. Remember the movie Iron Man, where Tony Stark creates this Jarvis system? So this Jarvis system could understand Tony Stark's language, and it could respond in doing some particular task, or by responding in a natural language. So if a Tony Stark says that Jarvis just create some program or just copy it from here, Jarvis does that task as well as it returns, yes, boss, I have done that. Okay, so that's the case of narrow AI, because it is only doing a specific task until and unless it kinds of like converts into vision later on in Infinity Wars. But I'm talking about the basic Iron Man movies here, where Jarvis was only doing some particular tasks. You must have also seen the movie Her, where a scientist falls in love with an AI assistant. That means whatever he's talking to the AI is also talking back, and he could not recognize whether he's talking to an AI or a human. Okay, and the AI could only do specific tasks of talking back in a natural language. So ChatGPT can also be categorized as a narrow AI because it is only doing some particular tasks like responding to our chats. Okay, so some people believe that ChatGPT will pass or surpass narrow AI, and it will come into general AI category in the next 10 years to come, so that it will evolve into that general AI category. So basically in AI, what we are searching is, we are searching for a particular algorithm that can do all the things that humans can do, or a combination of all these algorithms that can do all the things that humans can do. Okay, so at the time we achieve that, we will be achieving true artificial intelligence. Okay, so general AI. General AI is an AI system that will have the ability to understand, learn, and apply knowledge in a generalized manner. That means that it will be able to do a lot of different tasks similar to how a human being does. So if I talk about a human being can understand whether an image is of a cat image or a dog image, and it human being can also write an essay on cat and dog. He can also understand it from the voices of a cat and a dog barking. So all these tasks together a human can do in a generalized manner. And if an AI system will have that ability to understand, learn, and apply the knowledge that is there in the world, then that AI system will be called a artificially general AI, artificial general intelligence, or AGI. It will be versatile and adaptable. That means it will learn from the world and it will adapt to it. It will also have the understanding and reasoning capabilities. It will be self-aware. That means it knows that it exists in reality. And it will have human-like decision-making capabilities. If you would have watched movies like I, Robot and Chappie, then they depict a picture of AGI, or artificial general intelligence. So human beings create sentient beings which are just like humans. So if you have watched Chappie, in Chappie, what happens is human beings create a robot, and that robot falls in the hand of gangsters, and it learns and understands and adapts to the gangster environment. It acts and behaves like the gangsters also, right? So in iRobot, there is a faulty robot that gets consciousness, and Will Smith tries to kind of like prevent the human beings getting destroyed by all these robots. AGI is very much hypothetical at this stage, and that means that we only see the gist or the kind of like the vision in these movies, as true AGI does not yet exist. We are in search of this true AGI, and I was listening to a very interesting podcast by some AI researcher, that he was saying that a truly artificial general intelligence, if we can achieve that in the future, that will be the last invention a human will have to do, because all of the inventions after that will be done by the AGI system itself, right? So there is a quest of achieving artificial general intelligence, and I hope that in the next 10 to 20 years we'll be able to achieve that also. Okay, moving on to ASI, which is super AI. When artificial general intelligence will surpass human intelligence and will be able to perform any intellectual task that a human can do better than a human being, that will be called a super AI, or ASI. I was reading some of the answer, and they were saying that the task it can do better than humans, that we will call artificial intelligence. Generally, in scientific world, we call that ASI, or artificial super intelligence. Artificial super intelligence will have superior cognitive abilities. That means it could understand more than a human being can perceive the environment. It will be self-improving. It will have ethical and moral reasoning, and it will be completely autonomous. That means that human beings will not be able to control that kind of AI that we are going to develop. If I talk about movies, then if you have watched Matrix by Keanu Reeves, then Matrix is one of the most, it was one of the record-breaking movies in early 2000s, where machines they in future they achieve artificial super intelligence, and they make humans slaves, and humans are actually kind of like living in a simulated environment that is being created by these machines. And the similar one that you have seen by Terminator, which featuring Arnold Schwarzenegger. So human beings have surpassed, they have made machines which are artificially super intelligent like the Terminators, and they have the capabilities more than humans. So these are also hypothetical at this stage, at true ASI does not yet exist, and we don't know when we will achieve true ASI, or whether we should achieve it or not. And that's a very popular debate in the scientific world right now, which I am also going to have it with you. It's time for another poll, and the poll is: should humans ever develop super AI? I'm going to launch this question. You need to just answer this in a poll form. If you believe that human beings should achieve super AI, then say yes. And if you believe that no, human beings should not do that, then you write no. And let's see how much of you are divided in this debate. It's a very interesting debate that is happening in the world right now, and it's also for AGI, that means the artificial general intelligence, whether we should achieve that or not. And let's see how our participants in this internship think about this. All right, thank you so much. We have already 600 answers out of 900 people who are attending this. Those who are attending it from Zoom, you can just write this in the comments, and also the reason behind why human beings should attain super AI. And if you are against it, then why we should not. So that we have an interesting kind of debate around this topic of artificial super intelligence. Okay, so you just have to give me the answer in the poll format, and if you want to give me an explanation, then you can directly give to me in the chat. Dhanvi is writing to me that we should create one but with restrictions, and that's a very powerful point from Dhanvi. And Harsha is saying that AI can be dangerous, and yes, it can be dangerous, as we have seen in movies like Matrix and Terminators, where AI is coming back to bite humans only. And Uday is saying that technology will advance in exponential rate if ASI is developed. Then yeah, of course, because if we could achieve ASI, then imagine the ways that we can see the whole Earth and the whole universe. There are so many concepts that are hidden that human beings don't know. And I will tell you about one concept in my masterclass today, which was unknown to humans for the last 5 to 6,000 years of the history, and AI was able to solve that. Okay, so quite interesting session ahead. Thank you so much for people who are responding. I will just end the poll because of the time restrictions. So 740 people have answered. Those who have not answered, please quickly answer for the next 30 seconds. And I am also reading your interesting questions from the chat box. And Sahil is saying that it is going to happen in future, and it should be restricted. And Zia Agarwal is saying that AI can also watch those movies and will learn from them. That's a very interesting kind of debate, that AI will watch all these movies about Matrix and Terminator, and it will learn from these movies, and it will come to bite us. Very interesting debate happening in the chat box also. Shubh is saying that I don't believe we can create them. If we are able to, then no one can stop anyone from not able to read this chat, from creating them. So we will just have to not do it. Okay, we humans are slowly destroying our surroundings. Only a super AI can save humanity. And that's a very dystopian argument that I'm hearing from someone. And let me read the last one, as we have some time restrictions also. But I love that you are participating in this, and I'm reading all of your answers. And Komal is saying we can create super AI as yeah, because of the new answers, I think the answers just went. We can create super AI as humans' intelligence level is also increasing day by day. Yes, because we are also increasing our intelligence, and we also have that power of intelligence, and we also have that computational power with us to implement all the ideas that we have. It will be implemented in the future. Okay, so 59% of you are in favor of creating a super AI. That means that you are not afraid even after watching Matrix and Terminator. And 41% of you are still saying no, we should not create super AI. Human beings are enough as an intelligent being in Earth, and there should not be anyone who is more intelligent than us. That should be our ego also talking. But that's another debate for another time. Okay, so let's move ahead in our masterclass. We are here to learn AI. All right, so a lot of people confuse between AI, machine learning, and deep learning. And these are the terms that are in the market, and we hear them each and every day. Okay, thank you so much for responding. I'll not be able to read more chat answers now. So let's move ahead with our class. Okay, so a lot of people are confused in these three concepts, because these three concepts are somehow interchangeably used when we are talking about artificial intelligence. So someone is talking about artificial intelligence, they are also talking about machine learning, and they are also talking about deep learning. So Basically, what is the difference between them, or are they similar in, if they are similar, then similar in what way? I'm going to explain with a small and simple example. So basically, artificial intelligence is that broader idea of, just like you said, creating a program that can mimic human intelligence, right? So if we are basically creating intelligence in a machine, then that machine will be called artificially intelligent machine. Okay, so let's dive with a small example. I use cats as an example because I am a very huge fan of cats. I had a cat called Simba, and this is just to just in the memory of that cat. Okay, so I'll be using a lot of cat examples. So that's my explanation of why I use cat examples. Okay, so artificial intelligent agent. So basically, if we are creating AI system, and our goal of that AI system is to identify if an image is an image of a cat or not. Okay, so here is an image of a cat. And if we are designing an AI system, because as humans, we have that intelligence capability of distinguishing between a cat and a dog and an elephant and a tiger and all these animals, right? Because we have that that inference power, or we can detect some patterns in these individuals, in these animals, right? So if we are creating an artificial intelligent agent whose goal is to identify if the image is of an image of a cat or not, then we can create it in with different methods. So one method of creating that would be a rule based agent. That means that we define all the properties of cats in a program. Okay, so all these properties, what a cat has round eyes, cat has pointy ears, cats have whiskers, cats have a slim body, cats have a small nose, and whatnot. All these things we define in a programming, in a hard code way. So basically, we are writing these if-else statements. If an animal has round eyes, then it's a cat. If an animal has pointy ears and whiskers and slim body and small nose, all these rules we are writing about how a cat should look like. Then we will be able to create that artificial intelligence system, right? But that artificial intelligence, if we want to create, we will need a lot of memory, as well as it will take a lot of time to process all these features. Again, even if we were able to create something like that, if we give an image like this, okay, it also has round eyes, it also has pointy ears, it has whiskers, it has a slim body, it has a small nose. But it's not a cat, it's a dog, right? So even if we could design a rule-based agent which has features where we encode all the features of a cat, the AI system can still predict that it's a dog. Because we will not be able to write all the rules, because it will take up a lot of memory to detect all of these things. Okay, so AI can be achieved with the help of rule-based agents also, but the accuracy of these rule-based agents is not that much. So that's when machine learning comes into picture. So what machine learning does, it's a type of achieving AI. Basically, machine learning is a subset of AI. That means to get artificial intelligence, we can also use machine learning to create artificially intelligent agents. So what we do is, in machine learning, we don't create any rule. What we give to the machine is lots and lots of data. So we feed all these cats images. So there are only these images that I can fit in this computer screen, but we can feed tens and thousands of these cat images in a computer program. And what we will do is we will ask the computer program, we will use some algorithm, that machine learning algorithm, whatever algorithm that we want to use, and we will extract some patterns from these images. So because a machine is being trained with all these cat images, the algorithms will be able to extract certain patterns of what a cat looks like. It might differ from what an idea of cat is to humans. It will have a different way of analyzing these patterns. And on the base of these patterns, the computer algorithm will be able to differentiate whether an image is a cat image or a dog image. Okay, so machine learning is done with the help of data. So we feed that data. We don't use any rule. We don't define a cat eyes are round. No. So what we are doing is we are asking the computer, this is the data, this is how a cat looks like. We use a machine learning algorithm that extracts some patterns from these pictures, and it learns from these patterns how a cat looks like. That's why we call it machine learning. And then it will be able to detect whether an image is a cat image or not. Okay, so machine learning can be done with two methods. One is a classical machine learning, and another one is deep learning, which we are going to explain later. So classical machine learning uses mathematical modeling. So mathematical modeling of the data. You can use techniques like k nearest neighbors, KNN, or you can use classifiers, logistic algorithms to predict whether an image is a cat image or not. Or you can use decision trees or random forest. These are machine learning algorithms that I'm talking about. So even if you use these classical machine learning algorithms, their accuracy is just 30 to 35%. So that means that even if I'm using machine learning and using classical machine learning algorithm, that means that I'll be able to achieve only 30 to 35% of accuracy. That's when deep learning comes into picture. So deep learning is a type of machine learning. So machine learning can be done with the help of two types. One is classical and a deep learning method. So in deep learning method, what we did was we thought how a human brain works. So a human brain has these nerve cells, which we call neurons, right? So this is a structure of a neuron. So what happens in a human brain when we see a cat picture is we get these inputs from our eyes, from our nose, from our ears, and these inputs, or whatever we are receiving, are passed on to other neuron cells, and a combination of a billion neuron cells is what makes our brain. What we did was we modeled the similar structure in machines using mathematical modeling, and we implemented it with programming to achieve something called neural networks. So the neural networks are just like human brains. So these are trying to emulate human brains. Basically, they are. This is actually called a perceptron model in AI systems. It's there are certain discussions whether we should call it artificial neuron or not. But basically, it is emulating how a human brain is working, not in a complete way, because human brain is very complicated to understand. It works in very different with different way, but a mathematical way of implementing a human brain in machine is called deep learning. Okay, sorry. So in deep learning, what happens is there is an input layer, and these neurons, they receive all of the information in this input layer, and then there is a hidden layer which gets adjusted according to the inputs, and the final output is thrown. So let's see how deep learning works in reality. Okay, so we have that cat images. We were trying to predict whether an image is a cat or not. So what we will do is in the input layer, we will feed all these cat images. Okay, so all these 10,000s of cat images, the more data that you will train your AI model with, the better your AI system will be. Okay, so this is a toy neural network. I have not drawn the fully fledged deep learning. There will be so many neurons in this, but these circles are called nodes, and these lines are called weights or branches. So if you are learning about graph theory, then they will be called branches. But if you are in artificial intelligence, they will be called weights. So these are called weights, and these are called nodes. Okay, so what we will do is we will feed this neural network with all these cat images, and all these cat in response to all these cat images, the neural network will learn certain patterns from these cat images, and certain neurons will get fired when they will see certain features in these cats. So suppose this neuron, it carries information that about the cat's images, that cat eyes are round and then they are pointy. So it will extract that pattern, and it will get fired whenever a round or a pointy image is there. Okay, round or a pointy eye is there, so it will get fired. It will detect cat's ears, it will detect cat's patterns, it will detect cat's tails. So a combination of all these nodes, these weights and biases will happen because of all these cat images that I'm feeding to this neural network, and a combination of this will lead to an output of a cat. Okay, so similarly, we will do the similar thing with dog images. So we will feed this neural network with tens and thousands of dog images, and it will extract certain patterns, and certain different neurons will get fired because of the response of the patterns that they are getting from the dog images. So different neurons are getting fired, and a combination of these neurons is predicting that this is a dog. So this is just a small way of showing how a classification by deep learning happens. In reality, it's much more complicated than that. There are algorithms which you use. There are convolutional neural networks that you need to use to detect all of this. And there are algorithms that we can use for logistic regression. And then there are different types of algorithms. So in a simple language, this is how it happens. That means that we are feeding lots and lots of images. The neural network is detecting certain patterns, and in response to these patterns, we are predicting whether the image is a dog image or a cat image. Okay, so whenever we feed a cat image now, this was the cat we were detecting, cat image now to the neural network, what will happen is when we were training this neural network here, sorry, okay, when we were training this neural network here with cat images, so these neurons were getting fired, right? And whenever we feed a cat image, so all these neurons which were firing, all these nodes which were firing, when we were feeding it, when it was learning from these cat images, will fire again and it will predict that it is a cat. So deep learning is a type of machine learning only where we are using these perceptron models or we are using neural networks to detect whether an image is a cat or not, or to create any artificial intelligence for that matter. So all these generative AI tools like ChatGPT and Gemini and all the AI tools that we have right now, they use deep learning because deep learning is very, very efficient in understanding natural language in a way that we speak. Right. So if we are designing a chatbot like a system which can understand our language and that can give answer back in that language, then we will need to use deep learning. Earlier, we were using classical methods like hardcore programming or classical machine learning to implement our solutions. Okay, so if it is clear, then I will just move back to one more time to this. So artificial intelligence is that general notion of creating an intelligent agent. It can be created any way. So right now, these technologies are in the forefront. I hope that in future we will design something which is entirely different from neural networks and that will create artificial intelligence. Okay, so we can create artificial intelligence through rule-based agent or any other thing. Machine learning is one way where we use data to achieve artificial intelligence. Deep learning is a way of doing machine learning using neural networks to achieve artificial intelligence. Okay, so this is clear, and we move ahead. And I have one more poll question to you, which is if you have this is just to check if you have learned this concept from the lecture or not. Okay, so this is question number 3, I guess, and I'm launching it right now. Okay, so the question is, AI can be achieved without machine learning. So you have to tell yes or no. AI can be achieved without machine learning. That means artificial intelligence we can achieve without machine learning. Okay, so a lot of people are saying no, and 32% are saying yes. Let's see when the poll ends how we end up. So the question is, AI can be achieved. So if we are not doing machine learning, can we be able to achieve AI? Okay, so that's the question for you. Okay, so I will take 30 more seconds for all of you to respond. Thank you so much for participating. The more you participate, the more you learn, because it will be a good way to revise your concepts. And if you are stuck somewhere in between, then I'll be able to solve that doubt also. Okay. So I'll be taking 30 more seconds. All right. So the question is, AI can be achieved without machine learning, and you have to say yes or no. And I'm just ending the poll. So 68% of you have said no, and 32% of you have said yes. Congratulations to those who have said yes, because that's the right answer. And why it is the right answer? Because as I told you, so the right answer is yes, it can be achieved without machine learning. Because, not to be confused by this, okay? Okay. So let me go. Okay. So just to clear this concept, so AI can be achieved with the help of rule-based agents also, right? So the only limitation is we will not be able to store all these rules in the memory. So if you can give example of chess playing agent, a chess playing agent does not depend on machine learning for artificial intelligence. Although that artificial intelligence will be less powerful, that means only it will be 30 or 35% efficient, but we will be able to achieve that also, right? So chess playing agent is an artificial intelligent agent. That means it can do things which a human can do. That's the simple definition of AI is right now. So we can achieve this with the help of rule-based agents also, like these, if we can program everything. But we don't do that because the accuracy is less. That's why we need machine learning. So if we say that, can artificial intelligence be achieved without machine learning? Yes, of course, it can be achieved without machine learning. And also, we don't know in future if we can implement, if we can develop some algorithm that can that is different from machine learning, but is very good in artificial intelligence. Then that AI can be achieved without machine learning also, right? So machine learning is a way of achieving AI. Okay, so that's the concept that I just wanted to clear, that it is not necessary to use machine learning to achieve artificial intelligence. Okay. All right, so let's move ahead into history of AI. So we have been hearing about AI for the last 5 to 6 years, and it has been so much into marketing. Every company is launching their own AI tool, and it has been hyped so much. But it has been with us for the last 60, 70 years. So we started first discussing about AI in 1943, when we were talking, when we did the evolution of neural networks. So in 1943, for the first time, we thought like, if a human being is thinking, how the human being is thinking on, or what makes a human brain, and we tried to mathematically model it. We could not program it, or we could not compute it using machines, because we did not have those machines at that time. But we could do the mathematical algorithm. We could create the mathematical algorithm at that time in 1943. That's 70 years back. Okay. And this is artificial neural network, and we talked about artificial neural network and how we can create it in machines. If you have watched the movie The Imitation Game, it's about the machine called Enigma, and Benedict Cumberbatch is the lead actor in that movie. The Imitation Game, it tells about Alan Turing's story, and Alan Turing was the scientist who designed the first digital computer. And Alan Turing achieved that with in 1950s, when we had nothing, like no silicon chips. We had these bulky transistors that were used for this Boolean algebra to be implemented, and hence it could do certain tasks which humans could not do. So in 1950s, Alan Turing gave a famous Turing's test. Okay, so he said that, and this is very much valid in today's world also. That means that in Turing test, we test the ability of a machine, whether the machine is intelligent or not. So what happens in a Turing's test is there is an invigilator or an interrogator, and the interrogator interrogates with the machine, not knowing that he is interrogating with the machine or a human. And if the interrogator cannot determine whether he is interrogating, or the answer that is he is getting is from a human or a machine, that means he cannot differentiate between the answer if it is coming from a human or a machine, then that machine will pass the Turing's test. That means that that machine will be called an artificially intelligent machine. Okay, so Turing's test is the test of intelligence in machines, and if a machine can pass Turing's test, then that machine will be called intelligent machine or artificially intelligent machine. Okay, so that is very much valid, and whatever agents that we prepare in today's world, we test it on Turing's test, and if it can pass Turing's test, that means that it is an artificially intelligent agent. Okay. In 1956, for the first time, John McCarthy in Dartmouth conference that happened in Berlin said the term artificial intelligence. That means he coined the term artificial intelligence. That means he said that a machine which will have the same thinking, reasoning capabilities like human will be called artificially intelligent machines. Okay. And we are seeing chatbots in today's world. We are seeing it in all the websites nowadays, not all, but most of them. Like if we go to IRCTC, there is also a chatbot there called Disha, where you can just interact with the chatbot and book your tickets from there. A lot of companies have now integrated these chatbots into their own environments. We are also going to learn in this internship how to create our own chatbots right in the end of this internship. But we created the first chatbot back in 1966. And that was a rule-based chatbot, just like I told you, the rule-based AI system. So there were certain rules in which that chatbot will answer these questions. So you will ask the chatbot something, and chatbot will respond in response to the question that you asked the chatbot. So Eliza was the name of that chatbot. And if you go to Google and search for Eliza, you will find it in today's world also. You can chat with Eliza and you can see what Eliza answers in today's world also. So Eliza is very much live, but we created that one back 40-50 years back. That is in 1966. More than 40, that's 60 years back, right? And in 1972, we designed the first intelligent bot, and we designed it in Japan. Japan engineers, they designed Webot-1, and Webot-1 could understand human language, certain commands, and could do certain tasks like picking up an object from somewhere and putting it somewhere else. So Webot was the first intelligent bot. That means that we could design a humanoid system of intelligence in 1972. In 1974 to 1980 came the first AI winter. That means that the expectations with AI was growing a lot, and we were not able to provide the computational power to do all these tasks that we were expecting an AI to do. So one important task that human beings have always wanted to do is translation task, like translating it from one language to other language. But we were only focused on these rule-based agents. So we were only working with these rule-based agents, right? So, but rule-based agents are limited because we cannot store every rule of a language. And a language has a lot of rules, right? Because it has a contextual meaning, it has a dictionary meaning, it is interpreted in various ways. There are jargons also in different languages, and different languages are spoken in a different way. So we cannot create a single rule that can translate one language to other language. So a popular example was we wanted to translate from English to Russian because of the American feud with Russia at that time. And if they wanted to translate the flesh is weak but spirit is strong, and they translated to Russian, there is some Russian, I don't know what the translation would look like. But when they translated back to English, it meant the food was lousy, but vodka was great. So that was not the desired result that we wanted our translation machine or agents to do. So the funding was very limited because we were not able to perform all these tasks. We did not have that computational power also in 1974 to 80. So AI research was stopped, and people did not want to do AI anymore. And we were focusing on doing more of the programming tasks and all. And then back in 1980s, that's again 40 years back, we designed something called expert systems. Expert systems were rule engine, but with a knowledge base. That means it had the knowledge of the world or the process that that you wanted to do. So we could program. So the concepts of dynamic programming and programming came in 1980s, where we could program a computer or a system to work efficiently in one area. Okay, so guys, if you have any questions, then please ask. I will answer these questions in the end. So if you have any doubts or any questions, I'll be answering only in the end. So if you are raising your hands for doubts and all, so I'll not be able to answer this because of the time constraints that we have. We have to finish this in time also. So I'll be able to answer all of your questions, all of your queries by the end of this class only. Okay, so thank you so much for being interested in learning more and more about this. But if you have questions, I'll be answering that in the end. Okay. So yeah, so in 1980s, we created the first expert systems. So if you can talk about an expert system, a chess playing agent is an expert system. That means it knows all the rules of the game, and it also has a knowledge base of all the counter moves that it can play in response to a particular move. So in 1980s, we were focusing more on designing this expert system. They were better in doing one particular work, and they were better in doing this one particular work better than human being itself. But still, it could not do general purpose tasks that we expect an AI to do. What happened in 1987 to 93 is we had one more AI winter, and the second AI winter was again, we were not able to do general purpose tasks with the help of these expert systems. They were very good in doing one particular task, but they were not able to achieve or do multiple tasks at the time. And also that was the time when internet was coming in boom, and we thought that internet would be that magic pill which will solve all the world problems, and we jumped into more funding and more research area was being dedicated to towards internet and developing these internet technologies, and AI was very much left behind in 1987 to 93. And in 1997, IBM broke, it was a groundbreaking research in IBM research center. So in our research centers, we developed Deep Blue, the IBM's Deep Blue, which was a supercomputer, and it could beat the current chess champion, who was Garry Kasparov at the time. So this was a significant landmark in the history of AI. That means that for the first time, we could design a system who is better than the best person in the world in that task. So a grandmaster, chess is a very complicated game. If I play chess for the next 60 years and a grandmaster of current time does not play at all for the next 60 years, I will not be able to beat that grandmaster because it involves a lot of practice. It needs a different kind of analytical brain. It needs a lot of logical understanding and all, and it also needs to play one move ahead of your opponent. So we could not designing a system which can beat the current human champion in chess at that time was a significant landmark in the history of AI. So AI research was boosted with this development in 97, and since then we have achieved so many landmarks in the history of AI. So in 2002, AI came in our homes as Roomba was the first company to launch its automatic vacuum cleaner. That means it could clean your house automatically. It could detect certain objects, and it could move from these objects, and it could not. It could just clean your house in that manner. And in 2011, IBM Watson win Jeopardy, a quiz show. So it was a significant development in natural language processing. So Jeopardy is a quiz show where the questions are asked in English language, and you have to choose different topics, and there are questions in these topics. You have to answer these questions. So IBM's Watson won Jeopardy, the quiz show, in 2011. And 2012 was the time when Google Assistant was launched. Google, which is OK Google, that you say it today. In 2011, Siri was launched, but it was not popular at that time because Apple smartphones were generally developing. And in 2014, for the first time, a chatbot called Eugene won a Turing test. That means that we could not determine whether the answers were being generated by a chatbot or a human. So it was so efficient. Eugene Goostman, you can go and search for Eugene in after this masterclass, and you will be able to interact with Eugene, and you can see that why that chatbot was that efficient in replying. So it was again a rule-based system, not like ChatGPT, but it could beat the human being in detecting whether the answer is being generated by a chatbot or a human. In 2016, and this was the thing that I was talking about when I was talking about super AI. So DeepMind, the Google's technology, DeepMind's AlphaGo defeated top Go players Lee Sedol. So Go is a game which is similar to chess, and it is played in China and all these South Asian countries for centuries. Okay, and in Go, what happens is you have a board and you have to capture the area with these white and these black dots. So the person who captures the more area in this board wins. So what happens in Go is, in chess there are only 64 blocks, right? In Go there are too many blocks, and there is a small Go, a small. This is a standard Go set. There are smaller Go sets than this also. The combination of moves in Go are so much that it exceeds the whole atoms in the universe. So the number of moves, the combination of moves in a Go exceeds the atoms in the whole universe. So you cannot make any memory system to store all these moves, all these counter moves that you will play against a player. Right? So there is no way we can create a rule-based system to play Go. Right? So what AlphaGo did in 2016 was they designed a deep neural network and they trained it with in playing Go, and it became so efficient that it could beat the top Go player Lee Sedol. And what happened in that interesting match? So there is a very interesting documentary in YouTube. If you go AlphaGo, the documentary by Google. So if you watch that documentary, there is a move number 37 that the AlphaGo plays, and that move. So that's a move that you play in Go. So move number 37, which AlphaGo plays, that move had never been played by any human in the whole history of Go. That means for the past 5 to 6,000 years that we have been playing Go, nobody had played that move, or nobody would play that move. And that move led to AlphaGo winning the game. And that was a significant development in the world of AI. That means that AI was opening doors of knowledge to humans that was beyond human capacity. That means that nobody in the history thought that this move can also be played and the game can be won from that move. So as you were talking about super AI and artificial general intelligence, suppose if we create this, how we will perceive the whole earth and the universe will entirely change, because AI will now give us those dimensions which we are not able to reach as humans. Okay, so this was a significant development in 2016. In 2017, transformers was the concept which are very good in translating language from one language to another language. And also these are the building blocks of all the technology that we will see today. In my next masterclass, I will take a deep dive into the transformers and how they work and how natural language processing is being done and how computer understands language. So it's a very, very exciting second masterclass, but I will explain transformers deep therein only. In 2018, OpenAI released ChatGPT, and after ChatGPT, there have been so much advancement in AI. It has been a part of our life. Netflix, if you see the recommendation engine, they are also using AI to recommend you content. So even if you're interacting in internet in any ways, there is a AI technology that is there in the system. All right. So after 2018, significant development has been done in AI that we will talk about in the by the end of this masterclass. So a quick poll time. We have been talking about history of AI, and I was saying that for the past 60, 70 years, we have the concept of AI, and we have been able to develop some significant tools in the past also. That means that in 1966, we designed our first chatbot. So what can be the reason behind the rapid development of AI in the last 8 to 10 years? Okay, so I am just going to open the poll for you. Just think and then answer. Just don't answer it instantly. Read the question and answer the question. Okay, so the question is, what can be the reason behind the rapid development of AI in the last 8 to 10 years? Okay, so first is decreased interest in technology field and popularity of social media. B is decrease in data availability, low computational power, complex algorithms. Third one is advances in computational power, availability of data, and efficient algorithms. And fourth one is reduced investment in research and development. So think about this. Read the question very carefully. Read the answers, and then give your answer. All right. So I will also give you next 30 seconds so that all of you can answer. Please do that quickly so that we can end this lecture on time. Okay. So I'll just wait for 30 seconds. Okay, please remember that no answer is a wrong answer. So please participate in this. This will also test where you are learning. And if you are learning something wrong, I will correct it in the meantime. All right, so we have reached 600 students have given the answers. Those who have left, please give it fast so that we move on in our class. All right, so I'm just going to end the poll and going to show the results. And 89% of you have said the right answer, that is the advancements in the computational power, availability of data, and efficient algorithms. We have been able to achieve AI in the last 8 to 10 years. And we are going to kind of like explore the importance of all these three things. Thank you so much. Those who have answered, 89% of you have given the right answer. Those who have given the wrong answer, this is an opportunity to learn that there is there is no increase in AI because of the popularity of social media. Although there are social media channels which are using AI, like Instagram as well as uh, Snapchat and all these things, but there has no decrease in interest in technology fields, and there is also no decrease in data availability. Low computational power will not be able to achieve AI. So the right answer is the third one. That means that we have advanced in these three fields: computational power, data availability, and efficient algorithms. And I'm going to explain these three concepts in detail. Okay, so as all of you, as 90% of you have said that because of these three technologies, access to a lot of data and storage of that data, access to computational power, and machine learning algorithms, these three technologies played a huge role in designing the AI systems that we have in today's world. Just a little example of how data plays a big role and what we have developed in these 60 to 70 years. IBM designed its first hard drive in 1956. So this was the first hard drive that we had and that we designed in 1956. And this hard drive had to be transported in an airplane. So it was 1/4 of a room. Can someone guess the weight of the first hard drive that was launched by IBM in 1956? So again, this is a poll question. I'll be opening this poll to you. It will be fifth question. Yeah. Can you guess the weight of the first hard drive by IBM when it launched in 1956? I will just show you the picture again. So the picture that you see is this. This was the first hard drive, and it had to be transported in an airplane, and it was half of the size, 1/4 of the size of a room. So just guess the weight of that hard drive that we launched in 1956. It's just a guessing process. If you don't know the right answer, that doesn't mean that you are wrong. Just need to guess the right answer here. Okay, so it will be a quick poll. So I'll be just closing this poll in 1 minute 30 seconds. We've already passed 46 seconds right now. We have 40 more seconds to go. So please quickly answer. This is the picture of the hard drive that was launched in 1956. That means when we were talking about these neural networks and machine learning algorithms. So what is the right answer in this? Okay, so I'm still waiting for some more participants. 20 more seconds. Okay, so 62% of you have said that the weight was 450 kgs. I'm just sharing the results here. And that's the right answer. The hard drive that we designed in 1956 was weighing 450 kgs. Can you imagine that much of big hard drive? It had to be transported in a plane for some machine learning purposes if somebody wanted to do in 1956. And now imagine how much data it could store. So if you're thinking that it's a hard drive and it will store a lot of data, that was not true. This hard drive could only store 5 MBs of data. That means that for a bulky device like this, 450 kgs, it could store only 5 MBs of data. And we had data at that time also, but we did not have the capacity to store that data. So this poll has been done. In 2024, if I go to market and buy this memory card, and this memory card is just by the size of my thumb, and it weighs less than 8 grams, and it can store 2 terabytes of data. And that means that that's 10,000 times times more the data that I could store in that 450 kg hard drive. So we have done significant advancements in data technology. That means that we can store more data in less space, and we have that access to data. We have a lot of data also on the internet. We have data from Wikipedia, social media, Quora, GitHub. We have also data from weather devices, from sensors. We have data from astronomical data that we have collected from observing the whole universe. So we have access to all that data that we have collected for the thousands and thousands, hundreds of years of human history. And that data we can store now in very less space. And we have these cloud storage devices that we can access that data from anywhere in the world. Okay, so the access to data is one of the significant development that we have achieved in the last 50, 60 years, that we are able to do these challenging AI tasks in today's life. And data is very, very important. Without data, AI systems cannot learn, they cannot they cannot predict, and they cannot provide insights. So AI systems need data to train. That means we need data to train the system. Just like in the cat example, we were using 10,000 of cat images to train my system in detecting the image if it is a cat image or a dog image. We also need it for validation and testing. That means that once I train a model and I have that model of detecting cat images, I want to test it on cat images so that I know the accuracy of that model. So data is also used for validation and testing. It is also used for feature extraction. That means extracting certain patterns, certain predictions, or certain features from the data that we have. Also for continuous improvements, like if you are designing a self-driving car, then you need data from all the sensors of the car to tell you if you are going in the right path or not. So data is very, very important in designing any artificially intelligent machine. Also in decision making, like if you are making a decision on whether you should invest on a certain stock based on the historical data of that stock. So for that decision making process also, if you are talking about like autonomous cars, which direction you should go, you need the data from your sensors, from the cameras, from the proximity sensors, which direction you need to go. So all these things we need data in artificial intelligence. So then there is different types of data that we use for creating artificial intelligent machines. So the three types of data is structured data, unstructured data, and semi-structured data. So I will be explaining all these three types of data in detail. Structured data is highly organized data that can fit neatly into table rows and columns. And I will also let you know how these different types of data is used in different types of machine learning algorithms. Okay, so three types of data that we categorize data into three types. Whatever data we use for AI, one is structured data, one is unstructured data, and a semi-structured data. So a structured data looks like this. So if we want to predict some stock, so what we will do is we will put up all the company's name here, what time the stock opened, what is the high of that day, what is the low, what is the change, what is the volume that is sold on that day. So if we can define our data that we are working on in neatly organized table like this, then that will be called structured data. Structured data is labeled data. It knows which column is which information. So the first column has the information of company names. The second column has the information of when the stock market opened, at what value it opened, and the high of that day and the low of that day. So if you could arrange our data in a neatly organized table, row and column, that data will be called the structured data. So similar data, if we can see, there is a popular database called MNIST database. So if you talk about share market data, we can put that data in a neatly organized table. So that table we can use for training our machine learning model. So that data will be called structured data. And if we are training a machine learning model, so if we can label, so MNIST data is a database of handwritten digits. So there are 60,000 examples of handwritten digits. And we have labeled, if we label this data according to our own perception of what that digit is. So if this is 4, if this is 1, if this is 0, if I label this as 7, 8, 1, 2, 7, and 1. So if I can label the data according to what that data is, that will be called a structured data. That means I am already telling my machine, this is the type of data and this is the label of that data. Okay, so structured data is organized, it is labeled, it can be fit into neatly organized tables. Another type of data that we have in our servers or in our cloud is a type of unstructured data. So unstructured data, we cannot fit into any predefined structure, or we cannot fit into a table, or we cannot organize it into a predefined manner. So like social media posts. So social media posts can be random. People post about anything. They can post about technology. They can post about personal things. They can just post their selfie eating something, or they can just post some valuable information. So it is very, very difficult to organize a social media post into a table or category. So we cannot organize this social media post into any category. So the data that cannot be organized into any category, or that cannot be organized in a table, is called an unstructured data. So emails also are example of unstructured data. You can get emails of any time. They can be of scam. They can be from companies. They can be from banks. They can be from schools. They can be from your colleges. They can be from your personal family members. So emails also are a type of unstructured data. Documents also, again, an unstructured type of data, because there can be any information in these documents. Documents can be about articles, they can be about letters, they can be about anything in the world. YouTube videos also are a type of unstructured data. The videos can be about anything. They are random. People shoot random videos and we cannot categorize them into certain categories. Okay, so data that cannot be predefined into categories, or that cannot be labeled, is called unstructured data. And it is also very, very important data that we use in machine learning algorithms. And what are the advantages of this unstructured data? I will explain you in detail when we'll be talking about machine learning. Okay, so let's talk about the third type of data, which is semi-structured data. So if we could organize the unstructured data in some organizational properties. So suppose movies, let's talk about movies. So from YouTube videos, if videos are a type of unstructured data, then if we talk about movies, then there are certain genres that we can classify these movies into. Although the content of all these movies will be different, like drama movies will have dramas, comedy movies will have comedies. The content, the type of comedy will be different. Like it can be a dark comedy, it can be a light comedy, it can be a romantic comedy. But nonetheless, the pattern remains same in this. So a type of semi-structured data is a data which does not fit into a rigid structure, but has some organizational properties. That means that if we could classify all these movies into all these genres, like these dramas, comedies, action, anime, children, family, crime, critic choice awards. So all these genres, if you could classify these movies, then that would be a type of semi-structured data. That means it has a type of organization, but we cannot really say that this movie Ozark will be similar to Breaking Bad. Although the theme can be similar, it can be organized in this way, but in reality, it is an unstructured data. So similarly, if you can categorize your mails, like if there are social, if there are some update, if there are promotion, if you could label your emails like customer service ticket, fulfillment, new orders, outstanding invoices. Out of these emails, if you could label the type of emails in some category, then that will be called a semi-structured data. All the emails that we receive are a type of unstructured data. But if we could categorize some emails into certain types, then that would give a semi-structure to my data, and that will be called a semi-structured data. Okay. Let's move to a quiz quickly on the type of data. So a customer database that includes fields for customer ID, name, address, and phone number is an example of which type of data. I'll be just launching the poll again, and that would be poll number 6. Okay, I'm sharing this poll results, so I'll just stop that. Okay, and I'm launching this poll. Okay, so this is the poll, and it's live. Yeah, so just in this, tell me which type of data is this. So a customer database, it has fields like customer ID, it has name, it has address and phone number. Let me know which type of data is this. And is it structured, is it unstructured, or is it semi-structured? Okay, so just click on the right answer, and you will be getting the next 50, 60 seconds more for answering this question. Please read the question carefully. So a customer database that has fields for customer ID, name, address, and phone number. Which type of data is this? All right, so remember, participating is a very, very effective form of learning. So if you are participating, and even if you are giving a wrong answer, that means you are learning something from this. And it also gives a check to me whether I am leading you in the right direction or not. So thank you so much for all those who are participating in this poll, and I am really, really grateful for all of you, those who are answering. So I'll just end this and share the results. And 86% of you have said that it is a structured data type, which means that you are right. And you are right because the data has customer ID, name, address, phone number, and it is a labeled. These are all labels that we can give to the data. So it is a labeled data. That means it has some structure. It is a structured data. Thank you so much for those who have answered, and thank you so much. And I'm really, really proud that you are focusing in this masterclass and you are learning something from this. And okay, so next, let's go to the second thing that led to the development of AI, which is computational power. So quickly tell me which company has recently become the second largest company in the world, and the poll is here. Okay, so if you know about general knowledge, then which company has recently become the second largest company in the world in the terms of 2024 revenue? So first one is Microsoft. So that's a hint that I can give, that Microsoft is the first. There is a race between the second and third. So The recent news was that this company overtook the other company and became the second largest company in the world in terms of revenue. And we're talking about compute power, so just think about your answer before giving it enough hints for you now. Okay, so I will give 1 minute and 30 seconds to so that all of you can answer this question. We have already crossed 50 seconds, so there is good 40 more seconds for you to answer this question. Okay, so there is an interesting answer to this question that is coming in this poll result, but let's see if it leads to the right answer. So the first, the company which is largest in the revenue is Microsoft. So that's a hint that I can give. So you are free to not select Microsoft from now on. So Microsoft is the largest company in the world in 2024 in terms of revenue. So second largest is what you need to tell. Okay, so 1 minute 30 seconds have been ended, and I'm ending the poll and sharing the results. And 36% of you have said Nvidia, and which is the right answer. So Nvidia is the company which makes GPUs or graphical processing units, and these GPUs are these powerful CPUs. Basically, they can parallelly process data much efficiently than our conventional CPUs. So because most of the algorithms are that we are designing in AI right now requires GPU usages. So that's why Nvidia has surpassed the second largest company, which is the world is previously was Apple. So the first one being Microsoft, and Microsoft rose to the first largest company in the world because of their acquisition of OpenAI when they bought OpenAI and when they funded the OpenAI, and they used ChatGPT in their Bing search engines and all. So Microsoft is the leading company right now in the terms of revenue in 2024. Second one was Apple previously, but Apple was dethroned by Nvidia in the recent times. For a brief amount of time, Nvidia was running more than for a brief amount of time, Nvidia was first largest company in the world in 2024. It surpassed Microsoft, but then Microsoft has caught up with Nvidia right now. There is a neck-to-neck competition between Apple and Nvidia. So those who have answered Apple, the revenue is similar of Nvidia and Apple. So you are also not wrong in your answer. Meta and Tesla are way behind in terms of revenue in 2024. Okay, so and why it has been like that? Because of the GPUs that they build, and because of the GPU technology. So I will just play this video from IBM, and it explains GPUs. But for that, I will just stop my sharing so that I can share the sound also. Okay, so share the sound, and I just need to. Okay, so yeah, let's play this. Okay, it's not working right now for me. So I'll just, what I will do is I'll share the YouTube link to that video. Okay, so let's go here. Let's go Zoom. Okay, so I'll have to share it again, and sharing this. And Yes, this is the video.
So, hi, my name is Alex Hudak. I'm an offering manager at IBM, and today I'm going to talk to you about what is a GPU. So I get.
Okay, so I'll have to share it again. Just quickly go to Zoom. Okay. I just want to be sure that my sound is sharing. Yes. So, yeah.
Some pretty basic questions on GPUs, and that's what I'm going to go over today. First question is, what is a GPU? What is the difference between a GPU and a CPU? So I'm going to represent those here. And then lastly, why use a GPU? And is it even important to use a GPU on cloud? So let's start first with what is a GPU. GPU stands for Graphic Processing Unit. But oftentimes people are more familiar with CPUs. So CPUs are actually made up of just a few cores. You can think of these cores as the power or the ability of a CPU to do certain calculations or computations. On the other hand, though, GPUs are made up of hundreds of cores. But what difference does it make? So the thing with a CPU is that when it does a computation, it does so in a serial form. So it does one computation at a time. But with a GPU, it does it in parallel. So the importance of these two differences is that with a GPU, you're able to do computations all at once, and very intense computations at that. So oftentimes when you have app codes, a lot of it's going to be going to the CPU. But then every now and then you're going to have an application that's going to require quite a bit of compute intensive support that the CPU just can't do. So it's going to be offloaded to the GPU. So you can think of a GPU as that extra muscle or that extra brain power that the CPU just can't do on its own. So there are two main providers of GPUs in industry, NVIDIA and AMD. Both providers manufacture GPUs that are optimized for certain use cases. So let's jump into that, because a big question I get is, why do I even need a GPU, in what industries and in what use cases? So the first we'll talk about is VDI. VDI stands for Virtual Desktop Infrastructure. So GPUs are created to support high-intensive graphic applications. Think about if you're a construction worker, right? And you're out in the field and you need to access a very high graphic intensive 3D CAD program. So rather than having the server right next to you, right in the field with you, you can have a server that's in a country away in a cloud data center and be able to view that 3D graphic as if that server was right with you. And that's going to be supported by the GPU because the GPU supports graphic intensive applications. Another example of this would be movie animation or rendering. So in fact, GPUs actually first got their name mainly with the gaming industry. Oftentimes they were referred to as gaming processing units because of this ability to provide end users with low latency graphics. But gaming is no longer the focus in industry anymore. It's a big piece of it, but now financial services, life sciences, and even healthcare are starting to get into it with artificial intelligence. So artificial intelligence has two big pieces to it. There's machine learning and there's deep learning. So now there are also GPUs that are optimized and created specifically for those applications. So there are some that are created for inferencing for machine learning purposes, and there are some that are created to help data scientists create and train neural networks. In other words, they're trying to create these algorithms that can think like a human brain. That's something that a CPU can simply not do on its own and requires GPU capabilities.
All right, so I'm going to stop it here and go back to my slides. So as the lady was explaining, GPUs are required for these AI applications like natural language processing and computer vision, because we need to process these data parallelly in order to get the desired results. And also, she was telling that if you want to create some app in a cloud, then GPUs are very much better in processing all this graphical information or graphical things, right? So, and she was also telling about the gaming industry. So if you have been playing games, that means that the rendering of the graphics has to be done with the help of GPUs. I'll be explaining more into GPUs, and we will be talking about GPUs in our next masterclass. That is more about transformer architecture, and these transformer architectures are being achieved inside GPUs. ChatGPT took 60,000 GPUs, and that to the top model, that's NVIDIA A100 GPUs, in order to train their large language models. So we'll be talking about how to train our large language models and how to use GPUs to train that in the next masterclass. This one is more of an introduction one, so we'll be talking about GPUs that much only. Let's move ahead in our slides. And let's talk about the third thing. We were talking about three things, the three advancements in the technology that has led to the boom of AI in the last 8 to 10 years, right? The first being the data and the access to data. That means that we can store large amount of data in a very, very small space. And we have all of that data in the whole world that we have stored for the last 100 years. And then in the next, we were talking about the computational power. That means that we have now these powerful GPUs which can process data parallelly and in very, very fast and efficient way that we did not have before. Let's talk about the machine learning algorithms and the type of machine learning that we can do and the efficient algorithms that has led to the development of in the past 8 to 10 years. So a simple way of saying that the advancements in machine learning is that you have these smartphones that you can unlock with the help of just by looking at your smartphones. The object detection or the image detection technique that the algorithm uses is so efficient that it can work in the Snapdragon processors that you have in your smartphones. You don't even need to require or use a computer to process that algorithm. That means that we have made simpler algorithms that can work on very, very less computational power that has led to these advancements in technology in AI. So machine learning can be done in three types. One is supervised learning, unsupervised learning, and reinforcement learning. Suppose I'm designing an agent which can detect these cat images, right? So we will learn about how to achieve that agent with the help of machine learning and how we can do machine learning in three ways. The one being supervised learning, unsupervised learning, and reinforcement learning. So let's dive deep into all three methods. So the first one being supervised learning system. So we are talking about machine learning algorithms and how we can achieve artificial intelligence using machine learning. So how we can use machine learning is there are three ways of training a machine. One way is by supervising the machine. That means by supervised learning method. Okay, so suppose you are a store manager and you want to design a self-checkout system. That means the customers are coming in the store, they are picking up any fruit and they are going to this checkout machine and they are showing that fruit to the checkout machine, and the machine is detecting the fruit, which type of fruit it is, and the price of that fruit. Okay, so our goal is to design that system. Our store has these 5 types of fruits: apple, mango, guava, watermelon, and banana. So one way of achieving machine learning is through supervised learning. What will happen in a supervised learning is that we will take pictures of all the fruits that we have in our store. So suppose we took a picture of apple, we took a picture of mango, we took pictures of guava, we took pictures of watermelon, we took pictures of banana. And we labeled these pictures according to what fruit it was. Okay, so what we are doing is we are putting label data, we are putting structured data into our machine learning algorithm. Okay, so this is apple, this is also an apple, this is also an apple, this is a mango, this is a mango, this is a mango, and guava, and watermelon, and banana. So what machine learning algorithms do, it will detect certain features. So we will do feature extraction. That means that we are detecting certain features of these images. So the machine learning algorithm will detect that this apple is red, and it is round, it is shiny, red, round, and shiny. So these three features it extracted, and on the base of these three features, it is detecting that it is a apple. Now, mango is yellow. It has a slightly elongated shape. It is not exactly round. Guava is green and round. Watermelon has these stripes, or watermelon will be a darker green in color. It will have a red pulp inside. Banana is elongated. It's yellow in color. Okay, so machine learning will detect. So remember these neural networks, right? These neural networks, these weights and biases, they will adjust according to whatever features they are extracting from these pictures. Because these pictures are labeled, the machine already knows whether an apple is. So whenever a customer goes for checkout, if there is an apple, it will detect that it is red in color, it is round, and a red and a round object is apple as it is labeled by a human. So in that way, the machine will learn these features about all these fruits. Okay, so remember that in supervised learning, we are labeling all of our data. We are telling the machine that this is what this data is. One more thing of achieving that is to work with unlabeled data. That means that we are clicking pictures of all the fruits that we have in our store, and we are not labeling them. We are just feeding all these pictures to a machine learning. Okay, so algorithm. Now the algorithm will not be able to name these, but it will able to detect certain pictures, certain features of certain fruits, and it will be able to categorize these fruits into different qualities. So machine learning algorithm will tell that there is a fruit which has these green leaves above, and this has these thorns, and it is slightly orange in color. There is a fruit which is red in color and is round in shape. There is a fruit which is pear shaped and dark green in color. There is a fruit which is orange in color and is round in shape. There is a fruit which is a cluster of small round shaped green objects. There is a fruit which is brown in color and has some whiskers. So right now, all the pictures, whatever pictures that I have of all these fruits that I have in my smart shop, I will just click these pictures and tens and thousands of them, and I will feed this into these machine learning algorithms. So machine learning algorithm will classify these fruits on the base of their features. So it will extract these features from these fruits, and it will classify these pictures according to these the features. So one significant advantage of unsupervised learning is it can detect patterns which human beings are not detecting. Suppose here in this example, it will say that this red round object is an apple. This is also an apple, but it's a different kind of apple. And this is also an apple, but it's a different kind of apple. Now, after I get these results by unsupervised learning, that means the machine learning algorithm has detected all these fruits. Now I can tell the machine learning algorithm that this is pineapple, and these type of features are apples, these type of features are avocado, these type of features are oranges. And now I can design a system that can make a self-checkout system that can take the input from a user, and then it will enable the user to self-checkout. So way of achieving machine learning is through unsupervised learning, where we are not labeling any of our data, and machine is already from the algorithm, it is detecting certain patterns, and it is dividing all of the data into different categories. Now here, the significant advantage, as I told, is that I can give various pricing to all these three types of apples that it detected. Remember, in this case, when we were doing supervised learning, we might do a mistake of categorizing this apple with this apple. So this is an imported apple that we get from some other country, and this is a Himachal apple which is not exactly red in color. And also this is an Alfonso mango. This might be a Kesar mango. So in writing in a supervised learning, we might label all these mangoes as mangoes. But with unsupervised learning, what happens is, with this data, the machine already detects that there are three types of apples. Then we can label these apples later on in the later stages, that this is a green apple, this is a Himachal apple, this is an imported apple, and we can give various type of pricing to all these apples also. Next is the reinforcement learning. So another way of achieving machine learning is through reinforcement learning. So in reinforcement learning, we don't give any label or any data. So what we do is we provide a task, and if the machine does this task perfectly, then we reward that machine. and if it doesn't do that task, then we punish that machine. So it's similar to how you train your dog. So if you want to train your dog, so what you will do is you will use, if you want to train your dog to fetch the ball for you, okay, so you throw a ball and the dog is going there and it's catching the ball and returning back to you. So one way of training a dog is you throw the ball, and when the dog returns that ball to you, you will give a bone to the dog. That's a reward to the dog. And when it does not return the ball, you will not give the bone to the dog. So in the process of learning, dog will learn that whenever I return a ball, I will get a bone. So whenever you throw a ball, he will go and he will fetch the ball and he will return it to you. Okay. So one example of reinforcement learning is done in maze solving robots. So in maze solving robots, we don't tell specifically the robots what a maze is. So we know that we have to reach here at this point. And whenever the maze is solved by a robot, we give the robot a reward. And whenever the robot gets stuck somewhere, we punish the robot. Okay, so reward can be given not only on completion of maze, but also on right moves. So whenever the robot is not striking the wall, or it's turning in the right corners, then we are giving the robot a reward. That means for any good move the robot is playing, we are giving a reward. And when the robot is playing a bad move, then we are giving a penalty. So in many iterations, the robot will learn how to navigate this maze perfectly, so that to maximize the reward that is being given to the robot. Okay, so in ways of reinforcement learning with dogs, it is expensive because we have to buy the bone and give the bone every time the dog answers a right answer, fetches the ball for me. But in terms of machine learning, we don't even have to spend that much. We just give a positive 1 plus 1 if the machine is returning. So it's an example, plus it can be any positive value. So a positive value when it takes a right move, and a negative value whenever it takes a wrong move. So in our example, if we want to train our machine learning using reinforcement learning, so what I will do is I will show the algorithm these images. If it detects that it is an apple, then we will give a reward. And if it detects that it is a mango, we will say, no, it is not a mango. So you get a punishment. And in that process, so it's a very iterative process. So we will keep on showing it the images. And if it detects the right image, then we give a reward. If it detects the wrong image, then we give a punishment. In that process, what it will do is it will adjust its neural network, its weights and biases, so as to maximize the reward. And it will train in a way that it always detects the right answer. Okay, so there are 3 ways of training a machine learning model. One is the supervised learning, where we are labeling the data. The another one is unsupervised learning, where we are not labeling the data. We are just giving all the data that we have to machine learning, and the machine learning is predicting through is extracting some features or trends. And the third one was reinforcement learning, when we are giving a reward when the machine learning is predicting right, and we are giving a punishment when it is not predicting right. Okay, so a quick poll question before we move ahead in our class. There is just 10 minutes left in this class, so we will just quickly do that. And the poll question would be the 8th one. And yeah, it is live. So Rahul is training on an AI system to detect the fault in tin cans. So first read the question carefully. A lot of people are just giving me answers like that. Read the question carefully and then answer the question. Okay. So Rahul is training an AI system to detect fault in tin cans produced by a company. He uses a lot of pictures of tin cans and labels each correct tin can as good and a defective tin can as bad when he's training the model. So what type of machine learning is he using? Is he using supervised, unsupervised, or reinforcement learning? Okay, so the question is, Rahul is training an AI system. He's detecting a fault in tin cans. So when he uses a lot of pictures of tin cans and labels a correct tin can as good, a defective tin can as bad to train the model. So what type of machine learning is he using? Is he using supervised, unsupervised, or reinforcement? There is a slight, it's a little bit of tricky question. If you read it carefully and then give the answer only, then you will be able to give the correct answer. So I'll just wait for the next 20 seconds for all of you to participate. We'll be moving ahead in this. Okay, so quickly give the answers, and then we will move ahead in our class. All right, let me just end the poll here. 70, I've got answers from more than 80% of participants. So I'm just ending the poll here. So I'm sharing the results, and there is a confusion between supervised learning and reinforcement learning. So 61% of you said supervised learning, and you are right. Congratulations if you have said supervised learning, because he's labeling each the pictures of tin can, the correct tin can as good and a defective tin can as bad to train the model. Now it can be confusing because reinforcement learning is also rewarding for good and punishing for bad, but there is no mention of reward here. The mention is only of labeling, right? So he's labeling the correct tin can as good and a defective tin can as bad. So it will be a supervised learning because he's labeling the data. The confusion here might occur because of the good and the bad, but if he was giving a reward for each correct can and giving a punishment for each defective can, then that type of machine learning would be a reinforcement learning type of machine learning. Okay, so just to clear that out, he is not rewarding it as good or bad. He is just labeling the correct tin can as good and defective tin can as bad. Okay, so in supervised learning, we label the data. In supervised learning, we don't label. The machine learning extracts features from the data itself. In reinforcement learning, we just provide a reward for a right a prediction and punishment for a wrong one. Okay, so let's move ahead. And okay, so now with the help of these three technologies, that means access to data and computational powers and machine learning algorithms, we see AI everywhere. So AI can recognize speech and images, as you see Alexa and the image recognition system in your smartphones, as well as Siri in Apple. It can also translate languages from one language to another language. You must have used Google Translate to translate it from one language to another language. And AI can also recommend you content on the base of whatever you are watching. So if you are watching thrillers, then it will recommend you all these thrillers only. That it recommends me Stranger Things because I'm more interested in thrillers and this psychological shows. And also you can see this recommending content in Amazon. So if you buy something from Amazon, it learns from your past behavior and it predicts what is the thing that you might require in the near future. Also, AI is being used to automate tasks. So in this assembly line, the AI robots are autonomously doing machine assembly. So in this case, the car assembly, and no human involved in this process. So it uses computer vision as well as machine learning precision to detect and to fix these parts in this assembly line. Also, AI is being used to predict trends. So trends in weather, whether it is weather forecasting or stock market trends or trends in any of the sector. If we have enough data, we can predict where the market is going to go or where the weather is going to happen. Like what is the weather that is going to happen tomorrow or the day after. So it is used for predicting trends that can save a lot of lives as well as a lot of money and finances for that matter. AI is also being used for making decisions. And I was listening to a very interesting podcast where in Africa, so basically in Africa, the farmers, they are designing these. So farmers grow tapioca plants. So tapioca plants is a kind of like potato type of root. And the tapioca plants were suffering from these diseases. So, and the farmer had to always contact to a farming agency and then call an expert, and then the expert will analyze the plant and will detect where the disease is in the plant. So what they did was they trained a machine learning model on the base of all the images of these plants, and the AI algorithm could predict whether the plant was healthy or not. And the farmers could cut the affected part of the plant, and the plant grows healthily after that. So it helped the farmers in making decisions on what part of plant to cut so that the plant does not get affected by the diseases that part of the plant was carrying. Also, in early stage of cancer detection, so if we could train a machine learning model on these cancer images, and if it could help the doctors to give a early stage intervention, many lives can be saved. Also, AI has been used to generate art, text, music, and all these things. We'll be learning about generative AI in the next masterclass. So this I will be explaining in detail in the next masterclass, where we will be learning how AI generates text and how AI generates images. And in the next masterclass, we will be learning on how to generate these wonderful text and images with the help of AI. All these images that you can see here are being generated by AI, and we cannot even distinguish whether they are being generated by AI or a human. Okay, so quick 5 minutes, and we are going to wrap up this session. So I'm going to open the last poll, and this has to be really quick, guys, because we are already extending our time limit. So I'm going to share this. So AI we have developed so far is helpful and has no harm for humans. So if you believe that the AI that we have developed so far is helpful and has no harm, then say yes. And if you believe that no, there is a harm also associated with the AI that we have developed, then say no. And this is live, so let's quickly do that. I'll be only giving 1 minute to answer this. This is a very fairly simple question. That AI we have developed so far is helpful or not. We are just to answer yes or no in this. If you believe that it is helpful, then you say yes. If you believe that no, it is not helpful, then you can say no in this. Okay, so 20 more seconds and I'll be ending this poll. And then I'll be quickly wrapping up today's session. Okay, so 1 minute has been over. I'm just going to share the results, and 74% of you believe that the AI that we have developed so far has no harm for humans, and 26% of you have said no. You might have your reasons. I have no time for reading your answers on the chat box. You might have your reasons of why you believe that the AI that we have developed is still harmful for humans, or why you believe that it is still helpful. Okay, so let's go into dangers of AI. That means that there are dangers of the AI already that we have created, and if we are not keeping in check the AI that we are creating, then it will create more dangers in the future. So the first one being job displacement, but that happens with every technology, right? I mean, when internet was invented, a lot of jobs were displaced. When computers were invented, a lot of people who used to do mechanical calculations, their job was displaced. When wheel was invented, the people who used to work on feet, their job was displaced. The key here is AI will also create a lot of jobs in the future, and the right way of seeing this job displacement is to adapt and adopt with AI, learn AI, and learn how to use AI tools, also to how to make your own AI systems. And you will be irreplaceable in the job market in the future for the jobs that AI is going to replace. Also, a lot of data that you are sharing is being used in this AI system. That means that your smartphones stores your data of your images so that to detect your face. So all of these, if mishandled and if the data is not secure, then it might lead to privacy invasion. That means that AI, the data that we are sharing, if it can be hacked by the servers that we are using it for AI systems, then it might also it will also have a privacy concern. That means that data can be used against you. That means to troll you, or to create a meme, or to defame you in social media. So all this sensitive data, like our photo, our information, the personal talks that we are doing in our day-to-day life, it is already being shared, and a lot of concerns have been raised in the past. Facebook was also lambasted for their data policies, that they are not being very transparent in what they store and what they are not. So it's already a concern. And in AI, that more data that we are sharing with AI, the more concerns of privacy invasion is there in in this. Also, there is a lot of bias and discrimination because the AI is being trained from the data on the internet, and the data on the internet is already biased and it is not discriminated. So it's an example of a Mid-Journey application which generates images. In November 7, 2022, when it was asked to generate the images of CEOs, it only generated the images of male CEOs, when in reality, male white CEOs for that matter, but in reality, there are a lot of CEOs in all the companies that are Indians, and Indians are categorized as browns, right? So the chairman of the CEO of even IBM company is Indian. And also, the CEOs are not only male, the CEOs are also females. But the historical bias of males being the more active in the business and more males being the CEOs led to this bias in the results by the AI. So there are a lot of concerns regarding the bias, whether we should believe the text that is being generated by AI or not will depend on whether we can remove the bias from AIs in the near future. So the data should be really, really not biased. There will also be ethical concerns, whether the AI will work in the benefit of humans or not. Suppose we are designing a self-driving car, whether that car will take care of our safety or will it just take care of reaching its goal. That means from reaching from one point to other point. So that also we need to think about when we are designing our AI systems. They should be working in favor of humans and not working against the humans. So there are certain ethical concerns also associated with AI. Also, there are security risks, like in a recent example on February 4, 2024. So in a call with a financial worker, so a hacker organized a call with a financial worker, and all the members in that meeting were deepfake of the company employees, and the financial worker paid $25 million to a fake employee of that company who was being created with the help of this deepfake technology. So there are also security risks involved, and AI has been used maliciously in many, many ways. Talking about deepfakes, all of our celebrities, they face it in day-to-day lives when a picture of their is being morphed on a picture of someone comes, and they have all these trollings and all this defamation in the market. And the Indian government has actually made a law on creating deepfakes. That means that we cannot create a deepfake of any personality, for that matter, and then can release it on internet. So it is being a criminal offense in India from now on. So deepfakes have also been circulated in the internet, and a lot of celebrities fall prey to this also. And also, it has environmental concerns. That means that ChatGPT, when it was trained, so a lot of CO2 is being released when we train a large language model, because a lot of GPUs have to be run continuously on the data that we are feeding these GPUs. And also, when we ask a query to ChatGPT, if we are asking the same query to Google, the Google takes 10 times less energy in generating that query. So suppose we are asking ChatGPT what is the fastest animal in the world, and ChatGPT responds with cheetah. The same if we ask Google and Google is responding it with a search result, the Google is taking 1/10 of the energy. So there are energy concerns, also the environmental concerns. If we can design sustainable systems so that we can develop AI without harming the environments, that would be the best fit for the world. With this, I conclude my lesson. That means that we need to design AI systems, and we need to attain advancements in technology, but we need to also keep in mind the dangers behind AI, that we are designing it sustainably and we are designing it according to the benefits of human beings, not in an unethical way. So thank you so much for joining in today's session. You have been amazing. You are very, very participative, all of you. I congratulate you in completing your first masterclass. This is an attendance link. This has also been circulated in the chat box. So please go to the chat box and use this, scan this. And if you are on the laptop, then you can use the link to fill in the attendance. There will be a masterclass code, and this I have dedicated it to Sam Altman of OpenAI. And Altman is the masterclass code. So yeah, you will have to feed that code there, so that it means that you have attended this masterclass and you have the code with you, and it will verify that for us. So quickly scan this one, and I am also going to answer some of the questions in the chat box. And attendance link is being shared by CSR Box team. And okay, so I'll be reading the questions.